Ladies and gentlemen, welcome to Physics 170, Introductory Physics for Scientists and Engineers here at UH Manoa in spring 2021. Your instructors for this semester are going to be Dr. Veronica Bindi. She's a professor in the physics department here at UH Manoa. And me, Dr. Matteo Palermo. I'm a postdoc in Dr. Bindi's group, and we're going to be working together to teach this class. That being said, I'm your primary contact for questions and concerns regarding the course. You can easily reach me via email at mpalermo@hawaii.edu for questions. If needed, we can also arrange a meeting with Zoom or Skype due to social distancing requirements, and I'll be happy to answer your questions and discuss concerns, if any. The narrator of the lectures for this class is going to be Christopher Light, who is the most senior PhD student in Dr. Bindi's group, and we work together for this class. So now I'm going to leave you to him. I hope you will enjoy this class and succeed in it.
Obviously, this course is going to be a little different this semester with social distancing required by the COVID-19 pandemic. The lectures for this course are going to be delivered as online videos, and they're going to be delivered in an asynchronous online format. That means asynchronous, different times. So the videos will be posted. You can watch them whenever you would like, but I am going to give you some suggested guidelines for this to try to make the course as effective as possible for you, okay? The videos are going to be posted no later than the scheduled lecture date for the material covered. Okay, the syllabus has a schedule on it for all the days that we would have had class, and I'll have videos for the scheduled material no later than the date we would have covered it in lecture. Okay, the videos are going to be available to you at all times after they're posted. So anytime after the videos are posted, you can go back and watch them again. Okay, they'll be free for your use after that. So with this course being delivered through online videos, I wanted to give a little guideline for how to use video lectures, okay? The first and most important thing is that you actively engage with the lecture, okay? Turn off distractions, don't have other videos or music or anything going in the background. Go to a quiet place, maybe put headphones on if you need to, that kind of thing. Make sure that you can focus your attention on watching and listening, okay? You want to actively learn during this time that you're watching the lecture. So, how do I actively engage with a video lecture? What I want you to do is think about what I'm talking about. What does it mean when I'm saying things? How did the new information that I present you, how does that change your understanding that you had of things before? I want you to do what's called deep thinking on this. I want you to be thinking about implications of what I'm telling you, well, guessing where I might be going next. This kind of deep thinking on material will improve your memory and your learning of the material. You're much more likely to be able to recall it later if you thought about it more deeply at the time that you're kind of committing it to your brain, okay? So I want you to actively follow along with these videos instead of watching them like you're watching a sitcom or something like that. Don't just sit back and do it like you're watching TV. Be like this little guy here, face glued, nose inches away from the screen, ready to watch, okay? Be attentive, be actively engaged with it, okay? Think of little kids watching kids shows where they ask them a question and the little kid screams the answer at the TV, okay? Think more like that, not having it on in the background like a sitcom while you get on Instagram with your phone or something like that. Actively engage. Make this the focus of your attention. Okay, so with that being said, there are a couple drawbacks with video lectures. So with a video lecture, I can't ask you guys questions to make sure everybody's following me. You guys can't ask questions of me if I say something unclearly. We can't do the class like a dialogue, like maybe I would prefer, okay? So those are drawbacks of the video format. So what are the advantages of it? How do we take advantage of the fact that it's a recording? Number one, remember that you can pause the video. if you're engaged in this kind of active listening, this attentive watching style, remember, if you start to fall behind, if you start to feel like I'm going too fast, you can pause the video. And for the love of all that is holy, do not watch it on an increased speed. Okay, I know we often listen to podcasts at greater than 1 times speed, but that's for a very passive listening. Okay, that's just noise that's going on as you're doing other things, as you're working out, or as you're doing something else. That's for a much more passive style of listening. For this, please watch it at normal speed. Think about it. If you find that it is going too fast, pause it. If you're falling behind, if you want to think about something a little bit more before it goes on, pause it. Give yourself a chance to think without missing things that are being said in the lecture. And also, you can take advantage of this pause. One of the things that you can really do with your active engagement is when I'm doing a problem, when I'm demonstrating a problem in the class, you can do the problem along with me. You should pull out a piece of paper when I'm doing a problem in one of these lectures, and you should do the problem together as I do the problem. This is a much better way for you to engage with it. This is a much better way for you to internalize the kind of tools that I'm trying to give you. When you're doing that, you can pause it and you can try to take the next step before I show it. And then you can hit play again and see if our steps match. The next thing you can do, you can rewind. So if you didn't understand something, you feel like you missed something, and you're suddenly lost, you don't have to just pause and think about it. You can also rewind and watch the same thing again. If you feel like something wasn't clear, you didn't understand something I said, you can always rewind it. So this is better than a lecture. You have the remote in your hand, right? You can pause me, you can rewind me, you can watch things again, okay? You don't have to just think about it and try your best to catch up if you're suddenly lost in the middle of a lecture, okay? You can rewind it, watch the same thing again, make sure you're on the same page, and then move forward. And the last thing I want to mention in this take advantage of the fact that it's a recording, is that you can rewatch. So you can watch it today, and then when you go to do your homework, if you're having a difficult time with something, you can pull the video back up. You can rewatch, relearn whatever it is that you're not getting that's making the homework more difficult. You can rewatch the lecture again another time, just if you feel like it was a tough one, or if you feel like you didn't understand everything that was being said. Take advantage of the fact that you can rewatch the lecture. The last thing, keep a consistent schedule here, okay? Watch the videos during the class time each day. The slow drip of information is much easier to take in than trying to do it all at once. So do not put off weeks of lecture and then watch all the videos in a row as you're cramming for the test. Cramming for tests is not a good practice for learning the material. And in this course in particular, the entire course is designed from top to bottom to reward learning the material, to reward actually learning physics. Trying hard to actually learn the material will result in a good grade in the class. Okay? Cramming for tests will not work for this class. Okay? I'm going to say that one more time. Pause, just to make clear here. Cramming for tests will not work for this class. Okay?
The test for this class will be administered remotely. A test time will be scheduled, and the test will be available to the students online only during that test time. Students will be given 1 hour and 10 minutes to take the test. This is intended to give you 1 hour to take the test and 10 minutes to scan the test and upload the file. So there won't be any in-person test during this class.
So, course materials. Each day that we would have had class, each lecture day, you're going to have 3 items of course materials associated with that lecture period. The first is the video lecture that we were just talking about. The video lecture is the most direct replacement for the lecture that I would have been giving in the lecture hall. Practice the good habits that I just outlined to get the most out of these videos, and watch them on the day that they're assigned. Watch them during class time, watch them as a replacement for going to class. Don't let them pile up, keep on top of them. The second thing that you guys are going to have is a reading from the textbook. So especially in an online course like this, it's going to be really important for you to read the assigned readings. It's going to be really important for you to get the material from a different source. So it's not just my voice that you're getting the material from all the time. You're hearing it from somebody else explained in a slightly different way. And the material from the textbook is always going to cover the same thing that's covered in the lecture. I'm not going to make the readings very long most of the time. They're going to be fairly short. And there'll be another chance for you to learn things. There's another chance for you to internalize the material, to really understand the material. It's a different medium, right? You're taking it in as reading instead of listening, and it's a different voice. It's going to be somebody that's going to explain things a little bit differently from me, and have a little bit different way of conveying that to you. So the third thing is going to be homework problems. And the homework is the single most important piece of your assigned learning material. It really is. The homework is your chance to practice what you're learning in class and from the book. So you learn, you get this knowledge from the lectures, from the videos, you get this knowledge from the book, and then your chance to actually apply it, to practice the skill of doing physics, is the homework. Physics is really a skill you build. It's not a set of facts that you memorize, and it's extremely important that you practice this skill. Practicing the skill means solving the homework problems yourself. What does yourself mean? What I'm saying is, you don't Google the answers to the homework problems. You don't use Chegg or some other resource that solves the problems for you. You must be able to do these problems yourself without outside aid in order to pass this class. I will post solutions to the homework problems a few days after they're assigned, but you really should be trying to solve these problems well before I post these solutions, okay? Work on them every day. The test questions are going to be extremely similar to the homework problems. If you need internet aid to solve the homework problems, you are not prepared to pass the test. So make sure that you're doing the homework and that you're doing it yourself. You're not using aids and then convincing yourself that you understand it. Make sure you're doing it yourself and that you fully understand it. The last little point here is you cannot learn physics if you do not do physics. Okay? Again, physics is a skill. We get these different bits of knowledge, these different principles, these equations, and the physics is really about applying these things, understanding how we apply them, when we can make simplifying assumptions, how we use them. So imagine you had a class that was piano performance. And so every day you got a piece that was homework. You had to go learn this piece. And you went home and you watched a YouTube video of someone playing this piece on the piano. And then test day comes around, and the test for piano performance is for you to come in and perform a Beethoven piece on the piano. And you're like, well, I've watched like 100 YouTube videos of people playing the piano. I'm going in, no problem. I just have to play Beethoven on the piano for the test, right? So that sounds absurd. I'm sure all of you are like, this is a disaster, right? You would go in, you would fail this test miserably. You wouldn't be able to play anything, okay? Physics is a skill in the same ilk, right? It is a skill that you practice. It is a skill that you do. So for you to come in to solve the problems on test day, you do have to have practiced before. You have to have built up this skill. You have to have this kind of robust skill of applying this knowledge in order to apply it on the test. So you need to do physics. You need to actually solve the problems in order to be ready to perform well when your knowledge is being tested. So learning outcomes for this class. When we ask students what they want from a class, it's generally pretty straightforward. Students invariably cite their primary desire from a class to be a good grade. You ask the student, what do you want from the class? A good grade so that I can move on and get my degree, right? I just want a good grade, have it in the rearview mirror, I'm good to go. But I want to think about a little bit about what a grade actually means. So when we take a collegiate level course and we get a grade in it, what is that grade supposed to represent? So a grade, what it's meant to represent is your mastery of the subject material. So in other words, getting an A in this class would say to a potential employer or say to a future teacher, I have an A level mastery of introductory physics. Okay? So what does that mean? What does it mean to have an A level mastery of introductory physics? That's where we get to what I want for you. And you can see already we have a page that's much more full than what most students want. Okay? So what do I want for you? I want you to have an understanding of physics at the introductory level. What does that mean? That means, first, that you should be able to understand, discuss, and explain to someone else basic physics topics. So if you were talking to a friend after you took this class, you would be able to explain to them basic physics topics like momentum, or energy, or inertia, okay? You'd be able to tell them what Newton's laws are, things like that. The second thing, you should be able to apply those same basic principles and equations to perform kind of back-of-the-envelope calculations. So what do we mean by back-of-the-envelope? Back-of-the-envelope calculation is kind of a shorthand for a simple approximation calculation. Okay, I don't need to get a computer and program every little detail of a system in to get the exact solution. Back of the envelope means kind of I make some simplifying assumptions, I do some simple math, and I have an answer that's pretty good. Okay, that's pretty solid. Most of the time you can do back of the envelope calculations to get things that are good enough for, say, building something. You can do back of the envelope calculations to figure out, how fast is a diver moving when they hit the water, things like that. Those are the kinds of things you're definitely going to be able to do at the end of this class. It means solving basic problems by applying some simplifying assumptions, applying the principles of physics that you learn in this class, and then solving some relatively simple equations. In introductory physics courses, the math doesn't get too wild. Okay, we just do some algebra, do a little bit of calculus every once in a while, and we're good to go. And then the third thing, you should be able to recognize and apply these principles in order to better understand the world around you. So you should be able to recognize when you see things moving and behaving in the natural world, what basic principles are involved, what basic physics is involved in the way things operate. You should be able to think about these principles and have an initial idea about the plausibility of things that you hear about. If you hear some device works this way, you should have a certain idea about the plausibility of that. If you hear about a perpetual motion machine, you should have an idea. You'd be like, well, it seems like that probably is going to violate thermodynamics. At some point, that machine's going to produce some heat and it's going to have lost energy. So we're going to have to put energy in to keep it going. Okay? Those are the kinds of things that you're going to be able to think about after you take this class. A really good example of this is there, I think, used to be a TV show. I don't think the TV show's on the air anymore, but I'm guessing probably still a lot of people have heard of Mythbusters. And the conceit of the show on Mythbusters was they would take urban legends, urban myths, and basically go test them scientifically or pseudoscientifically to kind of gauge the plausibility of the myth. Is the myth even possible, or did somebody just make it up from whole cloth? And when you're watching that show after you've taken a class like this introductory physics class, you should probably be able to guess at the beginning of the show when they present each myth how plausible it is before they even do the show. And you're going to be able to do it with pretty high accuracy. So those are the kinds of things that you're going to be able to do with the knowledge that you get from this class. So how do I bring your desire for a grade together with my desire for you to have this understanding of physics? So this part, what do I do so that we can both get the things that we want from this class? You get what you want, and you also get what I want for you. The first thing that I do is I provide you with the tools to learn the material. I try to make The videos, I select readings for you guys. I write homework problems for you guys. Everything designed around you being able to learn these basic physical principles and to be able to apply them. And I do the best job I can in the videos of explaining, of trying to make sure that you understand the nuances, the important things about each of these things. And I try to make sure that everything in the course aligns. The reading makes sense with the video. The homework makes sense with the reading and the video, okay? And I put all that stuff together to give you the best possible chance to actually learn the material. And then the second thing is, I write the test such that if you did learn and understand the material, if you did put in the effort, if you did do the work, and you understand the material now, you will get a good grade. Specifically, what this means is if you can do the homework without aid, okay, without outside aid, the test should feel about equally difficult. You should be able to do the tests as easily as you do the homework when test day comes around. The test questions are going to be very similar to the homework questions. So in that sense, we'll use that as a tool to make sure that we fit this requirement, okay, to bring these two desires together. And the test will be written such that if you have internalized the material and the homework has reached the point that it feels easy, the test will also feel easy. Everything is set up so that if you do the learning part, if you learn introductory physics, the grade part will take care of itself, okay? On the other hand, if you have not taken the time, if you have not put in the effort to really learn the material, if you have not practiced the skill of doing physics, of solving problems, the homework problems yourself without outside aid, the test is going to feel nearly impossible. Okay? If you can't do all of those things, if you haven't put in the appropriate effort, if you haven't gotten that learning done, the test is going to feel like no one in the world could pass it. So, this is not meant to be scary, okay? This is actually meant to be reassuring. What I'm reassuring you is, if you do the work, if you do honestly learn the material, I will make sure that the test does not blindside you and does not feel unfair. Okay? So the last point on this is that for this A, for learning the material, we have trust. Okay? So trust that I'm setting you up for success when I assign the material and when I suggest ways to use the material. So what do I mean by trust me that I'm setting you up for success? What I'm telling you is I'm designing the entire class to work so that if you follow what I'm telling you, the grade will come. And what this means is you don't have to blindly trust me, but the trust part, what I'm really saying is that when I say watch the videos without distraction, when I say that watch them at normal speed, when I say that you should actively engage, that you should solve problems along with me when I solve problems in the videos, don't think, I don't really need to do that, or that doesn't really apply to me, or something along those lines. That's for other people. Do it. What I mean when I say trust me is do what I'm telling you to do. If you do what I'm telling you to do, you will have the best chance to get a good grade in this class. Okay? That brings us to the grading. So here's your grade. Part of being fair is being simple. If it's too complicated, it starts to feel unfair. Okay? So our grading is simple. There are 4 tests throughout the semester. Your grade will be your average score on those 4 tests. That's it. It's that simple. Okay? No one test counts more or less than the other tests. And at least for now, the intended grading scale is this standard grading scale. I reserve the right to change that, to curve it a little bit one way or the other based on the overall performance of the class. But from the start, what we're intending is this standard grading scale, okay? So 4 tests, your average on those 4 tests, where it falls on this scale, that's your grade for the class. It's that simple. Learning physics tends to build on itself. So each new idea kind of relies, at least in part, on the stuff that we've covered before, all right? We use the the ideas from before as a springboard to learn the new stuff. So, given that reality, each test will be considered comprehensive. So, any material that's been covered in the class up to that point is considered fair game for the test. With that being said, the test questions will be heavily biased toward closely resembling the homework problems assigned since the last test. Okay? Again, like I've said a couple times before, the test problems are going to be very similar to the homework problems. So you can expect when you come in and look at the test for it to look very similar to a homework. And the questions are going to be very much biased toward covering material that has happened or homework sets that have happened after the prior test. So when you take the test, you will be allowed to have a calculator. In fact, you should have a calculator. Okay, I would strongly recommend it. One of the things that I would recommend with a calculator is that you have a calculator that you know how to use, so that when you're taking the test, you're not using up valuable test time trying to just operate a calculator that you're not familiar with. You're going to want to have a scientific calculator. Scientific calculator means that it can do things like powers and trigonomic functions. Okay, and I have a very simple scientific calculator. It's the only calculator I've ever done any kind of physics homework or tests with, from undergrad up to now PhD candidate. I've never used another calculator. It's very simple. You should be able to get one cheaply, okay? A similar one cheaply, and you really don't need anything more than this calculator. You will also be allowed to have a single page, handwritten note sheet for the test. The single page means both sides. You're allowed to write stuff on both sides of the page. I just want it to be one normal letter-sized piece of paper. I want it handwritten. I don't want it to be typed or printed in extra tiny font or anything like that. I want you to personally handwrite your note sheet. The point of this is that, one, making the note sheet is actually a valuable learning tool for you, and it'll help you learn the material that much more as you're thinking about which kinds of things should be on the note sheet. And two, I want to make sure that it's actually yours. Those are the only requirements for the note sheet. You can write anything you want on the note sheet. All right? If you want to write something like "stay calm, you got this," fine. If you want to put equations on it, fine. If you want to put when certain principles are usable, what kind of rules are involved in using certain principles, fine. Whatever. You can put anything you want on this one note sheet as long as it's handwritten and it's only one piece of paper. You will not be allowed any other aids on the test, okay? There are no outside aids. There's no using Google. There's no using Chegg. There's no asking anyone else. There's no other help, okay? There are no other aids allowed on the test. You have your note sheet and you have your calculator, and that's it. If you do have accessibility issues that require special accommodation for test taking, I need you to contact me before the test. Don't contact me on test day. Contact me before, and we'll work with Kakua to administer your test to meet any kind of special accessibility needs that you have. So make sure with anything like that you just contact me before the test, and then we can accommodate that. So the test is not going to be written to be arbitrarily difficult. There won't be unfair questions. It's not going to place unreasonable expectations on your ability. The test exists purely to test your knowledge of the material. The class is designed as a whole so that if you take my advice seriously, if you actively engage with the material, if you take the effort and time to really learn the material, the test should feel easy. On test day, you should feel like you're just solving another set of homework problems. It exists so that I can measure your understanding of the material, and it's not written to do anything else. It's not written to be difficult. It's not written to make people feel bad. It just exists so that I can assign a grade to your understanding of the material. And I cannot stress this enough. The course material is designed so that you're in full engagement with it will make test day easy, okay? Everything that we do in the class is designed so that you learn the material, and the test is written so that knowing the material makes the test easy. So this brings us to our next thing. Why only tests? So the only thing that I have in grading are these 4 tests. Why am I only using tests to calculate your grade? So we go back to the first thing we said about the grade, that it should reflect your knowledge of the subject. And the test is a chance for me to ask questions that allow you to demonstrate your knowledge. So you can take these questions and show me all the things you know, so that then I can assign a grade. And when somebody looks at that grade, they know how well you know physics. The reason I'm using this format is all in response to kind of a modern problem that we have of cheating the homework. In my experience, as both a physics student and as a teacher, in modern classes, the students are using the internet to complete the vast majority of assignments with outside help. So homework, projects, any kind of assignments that don't have supervision, basically anything other than the test, the vast majority of students are solving those using something like Google Chegg, something that basically solves it for them, gives them a solution that they can copy. Okay? This leads to a couple of undesirable outcomes. In almost every class I've taken or taught, nearly the entire class would spend the entire semester getting perfect scores on homework. That sounds great. It sounds like we have a whole class of students that know this stuff inside and out that could teach the class the next semester after it's given, right? The problem is that all those perfect scores on homework were basically because the students were all just Googling the answers to all the homework problems. So, first off, everybody has the same score on the test, so grading it is pointless. It has no correlation with your actual knowledge on the topic, right? There's no discerning between students this way. And because the whole reason that this happens is because students are Googling the answers to all the homework problems, it's just completely unrelated to your actual knowledge of physics. So in these same classes where everybody was getting perfect scores on all of the homework, the majority of the class found each test extremely difficult, okay? Many of the students found the test almost impossible. So why is that? Well, it's not a coincidence, right? It's not a coincidence that the perfect homework scores went with extremely difficult tests. The truth is, most physics classes, the test questions are a little bit easier than most of the homework questions. So the test was nearly impossible because by cheating the process on the homework, the students weren't getting any real practice in the skill of solving physics problems, okay? So they were basically living our example with the piano performance, where they were going home, watching videos or looking up solutions to problems, watching people play the piano, and then trying to show up on test day and play the piano. The two things don't go together, right? You must practice the skill in order to perform the skill on the day when it counts. So by not counting your homework for a grade, what I'm doing is I'm freeing you from any pressure to get the right answer on every homework problem. There's no cookie that you get, and there's no punishment waiting for you for right and wrong answers on the homework. You don't have to worry that your grade's going to suffer if you turn in homework without all right answers. You don't have to worry that you're going to be hurt if I use some kind of grading curve because you're the only student in the class who doesn't have perfect homework scores, and so you're behind everybody else from the start there. You don't have to worry about that. Your homework exists purely as your chance to practice the skills that will allow you to perform well on the test. If you don't get a right answer the first time you attempt a homework problem, it doesn't cost you anything but a little bit of time and effort. If you don't get the correct answer on a homework problem the first time you try it, you can go back and try it again. You should go back and do it again. When you look at my solutions eventually for the homework, if they're different from yours, you should revisit those problems. You can go back and reread in the textbook. You can go back and watch portions of the lectures again. It's your tool for assessing what your shortcomings are as far as your physics knowledge. That allows you to go back and improve those and get a full understanding of the material before you're tested on it. You don't have to get the problems right the first time you try, but you do have to keep working on them until you could solve a similar type of problem quickly and easily. When you can solve the same type of problem in the homework quickly and easily, that's when you're prepared for the test. You keep working on these until you could solve anything similar to every one of the homework problems. When that happens, you are prepared to go in and get an A on the test. So, to put it succinctly, if you could solve any problem that uses the principles required to solve the homework problems, you're prepared to get an A on the test. The test questions will be similar, and if you can solve any problem on the homework, or any problem that's similar to the homework problems, you have learned the material. You do know the introductory physics that we're trying to teach you in this class. So, solving the homework problems yourself and fully understanding each problem is the single most important source of learning in any physics course. Not only in this one, in any physics course, this is the most important source of learning, okay? So, let's highlight this point, and I'm going to say it one more time, okay? Solving the homework problems yourself and fully understanding what's going on in each problem is the single most important source of learning in any physics course. That is how you set yourself up for success. That is how you make test day a no-stress, easy day. Okay, so I've given a lot of advice about how to succeed in this class so far. So, how do you get a good grade in this class? Let's summarize a little bit. The bottom line, the main point is, you will get a good grade if you have a good understanding of the material, okay? You will. That is the way the course is set up. So how can you best learn the material? Let's go back for some of the points that we've said before. The first one, keep a schedule. Work a little bit every day. Don't try to cram weeks of learning into the few days before the test. There's no way you can absorb it and really fully learn it fast enough to make this work. You really need to keep a schedule on this. You really need to work a little bit every day. The assigned work in this course shouldn't be overwhelming. There's not a ton of it. I expect most of the video lectures to be actually a little shorter than the lecture period would be. So total video time, if I have you watch, 2 videos that I post or something, the total time of them I expect is probably going to be shorter than a normal lecture would be. But you do need to keep on top of it to fully learn it, okay? The readings won't be long. There won't be a ton of homework problems every day. But you do need to keep on top of it to fully learn it. If you let it pile up, it will start to become overwhelming. It will feel like there's too much to do if you're not doing it every day. Also, that slow drip really gives you a chance to learn things in a much more effective manner than the fire hose of trying to get it all in a week. That slow drip really lets your mind absorb each drop before you send the next drop in. So the second thing, do the homework. Okay? I'm back to the homework again. Being able to solve the problems yourself, as we defined it, without outside help, is the single most important learning task that you have in this course. It is imperative that you take the homework seriously, that you give it your full attention, and that you give it your full effort. All right? You must solve these problems on your own to be prepared to perform well on the test. The homework isn't graded, so there's no incentive whatsoever for you to use outside resources, for you to Google the answers to the questions. There's no incentive. Do it yourself. When you get stuck, Go back to the material, the source material, the videos and the readings, and figure out the problem. You will learn much better the spots you get stuck on if you go and solve those problems yourself, if you break through those barriers yourself. Again, this item cannot be stressed enough. How seriously and honestly you treat the homework will translate directly to your grade in the class. All right? Do all of the homework and make sure you fully understand every problem. All right? Understand all the physical principles, the equations involved, everything that went into solving every one of the homework problems. The next thing, do the reading. All right? Don't skip on the reading. I will try to make the videos as useful as possible. I'll try to give you the best explanations I can. I'll try to demonstrate how we solve problems using the principles that we're learning. I'll try to make the videos the best that they can possibly be to help you learn the material. That doesn't mean you should skip the reading, especially in a course like this where it's online, where we can't have a dialogue back and forth. It's really important that you get this material from more than one source, that you get it from a voice other than mine, and that you get it from a medium other than watching a video. The two mediums, the reading and the watching, both work together to help you learn the material. You can experiment with what order works best for you, whether you like to do the reading first and then watch the video, whether you like to watch the video and then do the reading, but always do both. Both things will help you learn, and you need both things to fully learn the material. If you're really stuck on homework, or you're having real difficulty understanding a topic, that's when we get to our last point. Ask somebody, okay? I do want you to solve the homework problems yourself. You need to be able, ultimately, to do them without outside aid, but that doesn't mean you can never talk to anybody. That doesn't mean that you can never seek outside help when you really are stuck. When you get to things and you go back and you look at the reading and you rewatch the video and you still don't get it and you can't understand and you can't solve the problem, talk to somebody else. And there's a little checklist that you can go through to try to get through these barriers as efficiently as possible. So the first thing we do, we ask somebody else from the class. Asking someone else from the class can be a really useful resource. Sometimes somebody else in the class will get something a little bit faster than you do. That's fine. Have them explain it to you, okay? You're already getting the material from me through the video. You're getting it from the textbook through the reading. And now you can add a third source. A peer can explain it to you. They can explain it in terms that help them understand it when they're trying to accomplish the same goal that you're trying to accomplish. That extra source can really clarify things. So that is a good resource, okay? Talk to somebody else. See if they can help you with something. If they can't, ask teaching assistants. Go to tutoring hours. Go to that the university provides. The university has tutoring times. Go to grad students that teach recitations for the class. Go to grad students that teach labs for the class. Go to room 421 in the physics department and just ask a grad student that has office hours there. Any of these things that are available to you as help for a physics class, go ask one of those people. They usually, if they're an undergrad, they've usually taken more physics classes. They've taken some upper division ones usually. Or they've at least, at the minimum, passed this class, right? If they're a grad student, they've taken many more physics classes, okay? They're taking much more advanced physics classes now. Maybe they can explain it to you in a way that's different from what I gave you in the video, from what you got in the text, from what you got from a peer. Maybe they can be a fourth source, and maybe that allows you to understand it. And then the third one. This one's not always necessarily after the other two, but often it is. The next thing you can do is you can schedule a meeting with me. All right? You already got it from me once in the video. But if you come back to me, if you are really stuck, if you can't understand some topic, if you're having real difficulty with a problem, if you really are stuck, I will try to explain it to you in a different way. I will try to make sure that when you meet with me, it's a different source of learning than just watching the video again. We can work together. We can find a way for you to learn this stuff. I will help you get through those kind of barriers. All right. We will find a way for you to understand it. Physics is often a very difficult class for people, but it's not impossible. You don't have to be some super genius to get it. If you're not getting it, it's just something with the material that's not clicking for you. We can keep presenting it in different ways until you do get it. Final thoughts here. Physics is the foundation of natural science, and this course represents a really valuable opportunity for you to learn about the world around you, regardless of your major. This can give you really valuable knowledge for recognizing fraudulent claims. This can give you really good knowledge for just understanding how things work, for having an intuition of how things should work. And if you're a student majoring in a hard science or in engineering, the approach that I'm giving you here and the habits that I'm trying to help you form, they'll help in all of your coursework for the rest of your degree. If you treat other courses like I'm trying to get you to treat this course, you should be able to have good results in all of your courses. If you're not a hard science major, if you're not an engineering major, most of this stuff will still work in a lot of your classes. Specific to this class, the entire class is designed to make this approach work. If you do the work, if you put in the effort, if you make it your goal to fully understand the material, the class will work for you. The tests will work for you. They will feel fair. You will get a good grade in the class. So, like I said a second ago, physics is often a subject that students find very difficult, but it doesn't have to be impossible. It doesn't have to be as difficult as most people think that it is. It is a skill that you practice. It's not like LeBron James jumping from the free throw line and dunking it. It's more like shooting a free throw. You don't have to have supreme innate ability to make half your free throws. If you practice enough, you can do it. Physics is like free throws. If you practice enough, you can do it. I'm going to try to give you opportunities to learn. I'm going to try to make those the best opportunities that I can. And I'm going to give you a fair shake at showing what you've learned. You will have a fair chance to prove that you've learned the material and that you deserve a good grade. None of this is meant to make the class sound scary. It shouldn't be scary. This should be encouraging. All you have to do is try to learn, and everything else will take care of itself. Actively engage, work through the assigned material each day it's assigned, and be resilient in your approach to the homework, okay? Keep going back. Be dogged. Go back to things you don't get. Go back to problems you couldn't solve until you're absolutely sure that you understand it. You could do it right if it was introduced to you out of the blue again, okay? If you do those things, you should be fine in this class. We can have some fun in this class, and we can learn things that you'll know and you'll be able to use for the rest of your life.